Okay. So, much like last week, there's kind of a an extended cooking time, hour and a half, right? So, so I'm going to show you the glassware setup. I'm going to show you how to flame dry glassware, okay, safely. And then once you guys are cooking, I'll talk a little bit about theory and mechanism and all that kind of stuff, okay? All right, so the first thing you're going to do is flame dry your stuff. So this is a very moisture sensitive reaction. And, you know, honestly, if you're the first class on Monday morning, this glassware is pretty dry. Now you'd be surprised, glassware actually adheres a lot of water. You know, even if it hasn't actually had water sprayed on it or whatever for weeks and weeks and weeks, it's made of silicon dioxide, and there's a lot of hydrogen bonding to be done with water. So, you know, but definitely for the classes that are going to come after you guys, then you know, they're going to definitely need to make sure they do a good job of flame drying this, or the reaction actually won't work. I didn't, so I think I got most of them, but I didn't do a real careful job of making sure I have all the glassware that I'm supposed to flame dry, because I'm just demonstrating for you guys. Can somebody can you grab me a striker? Do you know what I mean by a striker? So, striker to somebody to make flame, to make fire. Okay, perfect. Awesome, thank you. Okay, and so the most important thing I want to convey to you, everybody that has long hair, let's make sure it's up today. Yeah, you know, no big ponytail too that could flop forward. Just like I say in that thing, piping hot glassware looks just like room temperature glassware. So real easy to burn it, get it super hot, and then accidentally grab it and burn yourself. I was working with a student doing research stuff on Thursday, and it was his first day he's ever worked it. And then I said, okay, you know, don't touch it again because it's going to be super, super hot. And then I left him for like 5 minutes. How could it burn? So be careful. So the way I like to do it, and I don't know, because I'm a weirdo lefty, I don't know if I do it differently. Actually, I'm a weirdo lefty. I want those on that side and these on this side. So you want the glassware that needs to be flame dried on one side, the Bunsen burner on one side. Is that thing on? Internet, are you there? Yeah, internet's there. And then the bowl, the dry bowl, on the other side of the Bunsen burner. Now don't use, later on in the experiment, you're going to need an ice bath. Do not use these. We need these to stay dry, okay? The point of this is to sort of, once we've done flame drying that stuff, we're going to sequester it so you don't accidentally put your hand on it, okay? All right, so what you're going to do, when I flame dry it, I'm going to grab it, and grab it, don't grab it like that, because that can slip off better. You know, sort of go into these glasswares like that to grab them. You want to, especially if there was like a drop of water in there, you don't want to point this thing like a chimney stack right at your face, because it can like sputter up and stuff like that. So you want to, you know, kind of that way, nod at your neighbor and stuff like that. Okay, and when you flame dry it, it's interesting. When you flame dry the glassware, what you're going to see is you're going to see the glass fog up. Basically, in a sense, I'm going to heat this wall of the glass. That's going to get real hot, and all the water that's stuck to it is going to get driven off, and it's immediately going to condense on this side. So it'll get foggy. Okay? And you just keep going until the foggy's gone. Once the foggy's all gone, you know that your glassware is dry. Okay? Does that make sense? I don't know if you can, well, you'll see it when you do it. So, yeah, okay. Students often have a hard time, make sure this guy is working nicely, have a hard time lighting Bunsen burners, and the counterintuitive thing that you need to do so that it's not hard is you need to turn this on full blast. Students are always a little apprehensive until they put on this tiny little trickle. It doesn't light, it's filling the room with gas, et cetera, et cetera. So what you need to do is turn that fully on, which is when here's where the hose is, here's the lever. When the lever is totally in line with the hose and the little spigot, then it's on. And then we'll get it going, we'll make kind of a big flame, and then we can turn it down to a flame size that we like, okay? We'd like the flame as blue as possible. I forget if that means it's an oxidizing flame or, I don't remember, but we want it as blue as possible because you get less soot when it's more blue than it is orange. Okay? All right, so let's do it. Oh, perfect. You can adjust this little window down here, and see that's more yellow now, and that's nice and blue. Okay? All right. Shucks. This is kind of like the water faucets where it's like, it's off, it's fire hose. There we go. I like that. Okay. So now, hopefully, I don't know if you can see the fogging, but did you guys see the fogging? Sort of? No? I mean, once you do it, it will be very, very obvious. I'll kind of move it around. I don't just tend to sit there and cook it. I mean, this is very strong glassware, so you could. All right, and then I will gently put it down in there. Take this dude, make sure you've taken the plastic off your anything. Okay, you don't want plastic on here at all. You don't want the blue nuts on there, the O-rings, or the plastic part on this guy. Just keep going. Keep going. Keep going. Very good. These are hot too. I don't want to touch those. Do you see all that fogging? And you don't need to like, oh, it's foggy here, I better like bend up. Don't do that. Just keep heating on this side and the heat will eventually get to the other one. I think that's most of it. I guess I do recommend that you put your stir bar in your round bottom flask. That way you can be flame drying the stir bar too without having to try to pick it up with these tongs. Okay. All right, and that's basically it. Shut this off, not in use. Okay. All right. So, and then I can't remember what I specify in there. I think 5 minutes after your last piece of glassware. That's still all very, very hot. Will burn me. Get started on this part. Okay. And when that's cooled down, I'll show you the setup for the reaction. But I want to skip forward now since it's too hot to do that. You know how we do liquid-liquid extractions where, okay, we've got, we did our reaction usually in an organic solvent, but there's some inorganic stuff. And we want to, get byproducts away from our product. Oh, well, if I put in some water, the inorganic stuff will go to the water layer. All right, liquid-liquid extraction. You guys have done a number of them already, right? And the way we always do it is we do it in these culture tubes. We shake them up, and then we let the layers settle, and then stick a pipette down in there. And most of the time we're taking that bottom layer to separate it. Now we've got these two layers. The inorganic stuff went where it needed to go, and now we got to physically separate those two different layers. Okay, we do it a little laboriously, pipetting it out of the culture tube, right? Okay. So today we're going to do a liquid extraction, but we're not going to use a culture tube and pipetting and all that nonsense. We're going to use what's called a separatory funnel. This is just sort of one of the absolute classic pieces of glassware in organic chemistry. Okay, that's that guy right there. Okay. So what I can do, this guy sits nicely down in there. I can pour both of my layers, I can pour my organic reaction, and then I can pour the aqueous layer, whatever it is that I'm going to be using in there. Okay. I'll put that guy on. All right, now I've got my two layers. Remember, we're going to do the shake. Okay. The way we're going to do the shake here is I typically cup this with my palm. Okay. And then I'll go shake, little gentle shake. You don't want to build up a lot of pressure in here. And then I can just vent it by opening this valve. That's open, okay? Just like what I was talking about with the valve with the gas. When it's in line, it's open. When it is perpendicular, it's closed, okay? So vent, close again, shake, vent again, right? Shake. And then I set it up here. Okay. You want to always take that top off right away, all right, so that you don't forget to do that. Let it settle. Now you'll have two layers in here, and now the beauty of this piece of glassware, so I can take, one Erlenmeyer flask, and I can sit here, and I open up the valve, and I just let out the bottom layer, and when all the bottom layer is gone, and the top layer is almost reached the little thing, close it. Okay. And you can actually, you can slow down how fast it's falling by just closing it a little bit, type thing. Okay? Does that make sense? All right. And when we're doing this, we're going to be doing this with dichloromethane. Dichloromethane is a carcinogen. So at that point, once you are working with dichloromethane, you need to be working in the hose. Okay? Much less of a problem now that there's only 8 of us in here. All right. Okay. Awesome. Okay. I believe it's been 5 minutes. Still a little bit warm, but it's fine. Okay. So setup for the reaction. It's still pretty warm, actually. Okay. Is it 5 minutes, did I say in there, to wait?
5 to 7.
What's that?
5 to 7.
5 to 7. Talking too fast, I guess. All right. Yeah, that's all I need. Okay, so I don't have a stir bar in here, but pretend I do. The first thing you always want to do is, so this is a Claisen head. Basically a way so that we have 2 ports of access to the reaction. Okay. So I'm first going to put this part into my round bottom flask. As always, I put the no burger balloon nut on first. Okay. And then you put on the O-ring. Okay. You can sit on there like that. All right. And then we need a Claisen head on there. The Claisen should go on this side port, not on. Should go on this one, not on this one. Okay. But before I do that, actually, I'll put on the septa. This is a rubber septa. Okay. What this is going to do is keep it a sealed system. We want it to be a sealed system, but allow us to be able to stick a needle through there and add something to the reaction later on. Okay. So you put that in there like that, and then you take one side of it, bend it down, hold it with your thumb, and then put it around the other side, like that. Okay? All right. Now we'll put on the, do we want to put on the, no, first I will prepare the Claisen head. So we would like to, we want to keep this an open system so it's not totally closed. We're going to be adding things. We could evolve gas from this reaction. Typically, it's earlier that we evolve gas. So what I put in there is like a marble. Okay, and I'll push this down. right? And what I'm going to do is create a barrier of calcium chloride. Calcium chloride will grab any water that wants to go inside, okay? But it doesn't totally seal the reaction, so gas can't escape, okay? All right, and then I forget what I call for. Do this part carefully so you don't make a ginormous mess. Pretty much all the bottles that we're using today are hydroscopic, so let's make sure that after we're done doing our thing, we put on the caps. Calcium chloride's very, I would say, about ½ inch. Calcium chloride is fine. All right. Okay. And then another. Maybe it's just a chickpea, garbanzo bean. Okay. That goes in, and that will seal it. Now we're good to go. See, cotton, calcium chloride, cotton. Okay. All right, now you can put on the blue O-ring on that little joint. Put on the O-ring. It goes onto this side port. And that's how it should look. Okay. Let's clamp this too. So, once the reaction's going, the best way is probably to grab it by the Claisen head. Okay? But it does call for you earlier in the reaction to take off that Claisen head part so you can add your sodium borohydride and then add your tartaric acid. Okay, so there we go. Make sure you're using the clamps, these littler ones, okay? Not the big kind of awkward ones, but these little clamps right there for grabbing the round bottom flap. Make sure it's nice and snug in there and stuff like that. And then you'll be able to, with your septum on there, you used a septum before? I can't remember. Bad memory. Maybe not. All right, so we've got our needle on there. And now we can, while it's sitting in here and we're getting ready to add our ethyl acetoacetate, okay, we can puncture. You want to go right in the middle of the septa, kind of out towards the outskirts of the septa. It's really thick. It gets to be like ½ inch thick, so you don't want to try to stab all the way through that. You want to stab through right through the center. Add your stuff. It will be like that. Okay? Does all that make sense, guys? Don't fire that in there. Add it by portions. Make sure you weigh these. We already talked about that. Do the math and come and talk to me about the math. If it's weird, if you get a negative number, or you get well over a gram.